Solving trig equations with non-exact solutions. So, complete the following do these, then complete the following for 4 quadrants, blah, blah. Round all to 4 decimal places, right? So, if I'm going to have to do a bunch of rounding to 4 decimal places, then I'm going to let my calculator do it for me. Okay, so if you're good at rounding, great, but if you have to do a whole bunch of these, so go to mode, make sure it's in degree mode. Go down to float, and instead of float, you go over to 4 decimals, right? This is the number of decimal places you'll get. Hit enter. So now everything will be rounded for you to 4 decimal places. So in any numeric response that you've done to this point, if you've ever lost marks for rounding on numeric response, then be aware your calculator can round for you, right? And if you have to, so in this, because we have to do a bunch of them, let's let the calculator do the rounding for us. Okay, sine of 40, so let's just retype that. Sine 40, close parentheses, not 0.6428. 0.6428. Cosine of 40, cos 40. If you're done, you don't need to close the parenthesis. Like, it'll automatically throw in a closing parenthesis if you like. So 0.7660. 0.7660. You need the 0 on the end, right? I mean, who knows what it actually is? Could be 0.599 or something. And then the tan of 40, 0.8391. 0.8391. All right, complete the following table for the 4 quadrant angles that have a reference angle of 40. Round all trig ratios for 4 decimal places. Okay, so draw a diagram with a reference angle of 40 degrees, right? Now remember, this is the important stuff. Reference angles, the cast rule, all of that, right? Okay, there's my 40 degrees. What's the quadrant angle? What's the actual angle? 40 degrees, right? Quadrant 1 is nice. What's the sine of 40? All right, well, that's sitting up here, right? So we just copy that down. 0.6428, cosine 0.7660, and the tangent 0.8391. I need a reference angle of 40 degrees in quadrant 2. So there's 40 degrees. What's my rotation angle for the quadrant angle? 100, yeah, 180 minus 40, right? So 180 degrees minus 40 degrees, 140 degrees. What's the sine of 140 degrees? Yeah. 0.6428. What's the cosine? Negative 0.7660. What's the tan? Negative 0.8391. Quadrant 3. There's my 40 degree reference angle. What's my rotation angle? Or what's called here the quadrant angle? 220 degrees, right? So 180 degrees plus 40 degrees is 220 degrees. What's the sine of 220 degrees? Negative 0.6428, right? Remember the cast rule. What's the cosine? Negative 0.7660. What's the tangent? Positive 0.8391. Okay? Remember, all science teachers combust. Or add sugar to coffee. 40 degrees. Reference angle of 40. What's the rotation angle or the quadrant angle? 320 degrees. What's the sine of 320 degrees?
Negative 0.6.
Yeah. What's the cosine of 320? 0.7660. Positive. What's the tangent of 320? Okay, now that's the exact same thing you cast. So if I go like sine of 320, right, negative 0.6428, right, sine 40. Okay, so calculator will do this for us as well, right? It'll put the appropriate sign on there. What do you notice about the sine of the 4 quadrant angles and the sine of the reference angle? So the sine of the 4 quadrant angles and the sine of the reference angle. We'll say the magnitude is the same, right? The size. Is this true for the cosine and tangent ratio?
Yes.
Yes. So the magnitude is the same? Okay. So same value, just different sign, right? Positive or negative. Maybe we can use the word polarity, right, to indicate positive or negative. So same value. Magnitude is the same, and this is also true for sine and cosine. Or cosine and tangent. In general, for any reference angle, theta r, the 4 quadrant angles are theta r, 180 minus theta r, 180 plus theta r, and 360 minus theta r. So we're kind of hammering on this, right? We've gone through this before, we're going through it again. Repetition is good. By the 4th time through, it'll actually, start to sink in. So we've got reference angles, and we've got the cast rule, all signed in tan, and we've got the absolute value, right? Absolute value is the magnitude or size of the number. So the absolute value of the sine of 180 minus r is the same as the absolute value of the sine of 180 plus r, is the same as the sine of 360 minus r, is the same as the sine of r, reference angle. Okay? We can use these relationships and the cast rule to solve trig equations. Okay, here we go. This is the actual lesson, right? Solving trig equations, non-exact values. It's okay, we have a guess. Are you grade 12 and you're just bored because there's nothing going on?
I'm grade 11, but all my classes are grade 12.
Oh, so then it's just like, there's nobody there. I'm the only one. You can help us out.
I'll just be here for security.
Right? You could be guest lecturer. You could come up and do this, right? It's like old hat. It's like you could tell them what's Math 30-1 like. Go ahead. What's Math 30-1?
It's easier than this.
See? Marks go up. No, seriously. Right? Like, yeah. What was your mark in 20?
Well, I did the IB version first.
Oh, okay. So it was kind of.
I had 77 standardized, but I did some schooling at 100%, and then Math 30 got 92.
92?
Yeah.
And on the diploma?
I got 90.
90. You went down on the diploma. That doesn't happen. Not at this school.
But see, I've got Down syndrome.
Ah, yeah, down. Yeah. So my marks, they go down. Well, you would have benefited from the 70-30. It would have actually made absolutely no difference to your mark, I'm sure, if we could do the math. So, look, there's hope yet, right? See, marks go out. Now, why is that? Well, people start taking Math 30 a little more seriously than Math 20, right?
And there's replacement tests.
And there's replacement tests. Yeah, we do all that just to boost marks, right?
my first big test.
Yeah, not in 20. That's why 20 is harder. Okay, so look, here, trig equation. This is how you solve these. So, serious now. Pay attention to this stuff. Unless you're just dead set on 30-2 and then pay attention to this stuff anyway, you just still got to pass this course to get into 30-2. So, that's not actually entirely true. You can get like a 45, but. Okay, the sine of theta is negative. So which quadrant is it in?
G-A-S-T, so either in C or 1.
Yeah, so it's a quadrant 3 or 4 angle. Possible quadrants 3 or 4. How long is the trig unit? 30-1.
3 or 4.
Pretty long.
Yeah, it's pretty long. See, that's what I told you. Pretty long. Okay, so if sine is negative, we know that it's a quadrant 3 or a quadrant 4 angle, right? Now, related equation with the reference angle. What's the related equation with the reference angle? Same thing, you're just going to change this to positive, right? So we're going to say sine theta is 0.9659, right? Because reference angle is always an acute positive angle, right? It's between 0 and 90 and it's positive. So the reference angle, what is the reference angle? So we run second function sine inverse, right? So we go second sine inverse. So in other words, I'm saying you give to me the angle whose sine is 0.9659. And it says that angle is, let's go with 75 degrees, right? Rounded to the nearest degree, it's 75 degrees. So the reference angle theta r is positive 75 degrees. But the trig ratio, this guy has a sign, this sign of negative, which means that it's in 3 or 4. Kind of leaped ahead there a bit. So if we sketch that angle, we need a reference angle of 75 degrees in quadrant 3. So there's 75 degrees. And we need a reference angle of 75 degrees in quadrant 4. That's actually much smaller, but at least I can write a 75 in there. Which gives us these rotation angles, which is our solution, right? So what's this angle?
180 plus 75.
180 plus 75, right? Which is 255. And what's this angle?
360 minus 75.
360 minus 75, which is 285. Now you might say, well, why don't I just go into my calculator and type in the inverse sine of negative 0.9659. Now what do you think it's going to give me? No? It's going to give me the negative of this. He said, wiping his brow, because it actually did. So here's what happens. So you got to look at that and you're going to say negative 75, and then you can just like add 360, right, to get the 285. Okay, but you'll miss the 255 because you're just not thinking and you're just using your calculator. But what your calculator does is it goes, when you ask it for the inverse sine, inverse cos, inverse tan, it goes to the closest angle, which is either going to be in quadrant 1 or quadrant 4. If it goes into quadrant 1, that's cool, it's just the rotation angle. If it goes into quadrant 4, it's going to do it as a negative. So when you ask it, what's the inverse sine of this, it's not going to go over here, right? It will never go to quadrant 3, right? It'll be up here or here. If it's positive, it's going to be up there. If it's negative, it's going to be down there. So instead, we need to know the whole concept of reference angles and the Cass rule, right? And then you need that along with the first quadrant of the unit circle, right? You don't need the whole unit circle, do you? You need the first quadrant, reference angles, and the Cass rule. So let me ask you this: what's the sine of pi over 6?
Tired.
Tired. Think about it for a while. Okay, cosine of theta. The cos of some angles, 0.4851. What's the related equation? Just the exact same, right? We're just going to make it positive, unless it is positive, and then we're just going to write it down. What's the reference angle? Okay, so we want to do an inverse sine, inverse cos, or inverse tan of a positive angle, which is going to give us a reference angle, or it's going to give us a first quadrant angle. So we're doing second cos inverse of 0.4581. And we're going to round that. We'll just go to the nearest degree, right? So we'll call it 63 degrees. Okay, so the reference angle is 63 degrees. What's the sign of the initial trig ratio? Positive. Cast rule tells us that if it's a cosine, it's going to be in quadrant 1 or 4, right? Positive cosine, 1, 4. Sketch of the angle. Okay, need a quadrant 1 angle at 63 degrees, which leads to this rotation angle. And I need a quadrant 4 angle, 63 degrees, which leads to this rotation angle. And my solution is, bless you, 63 degrees and 297 degrees. Okay, you try the tan. So same procedure, right? Just run through the procedure. Give it a shot.
But I'm already over in 10 more.
Unrelated question. You sunburned?
I'm sunny.
I think you could burn. Like, based on that thing, right? They're trying to scare you out of tanning beds and stuff. Not that I recommend you use tanning beds. I don't. But it's like, oh, one use of a tanning bed will increase your chance of getting skin cancer by 85% or something, right? And it's like, you know, like a bad sunburn. Like when I was a kid, all you did was get bad sunburn. Because we actually played outside. I know this is a foreign concept. Go outside. We don't do that. We go from, well, if we do, we just make sure we get into the car really quickly and keep the windows rolled up and the air conditioning on if it's hot. We will not suffer from sun exposure. But if bad sunburns do you in, then that's it, I'm dead. I mean, I don't have a chance. Okay, so here's what we're going to do, right? Which I'm sure you're doing right now. Second, 0.7. Call that 38 degrees, right? Uh, 142. And 322. Actually, I should have known that because they're just 180 apart. Okay, so is that what yours looks like?
Yeah.
Good. Is that what somebody else's looks like? Just so I have independent verification from at least 2 sources?
Yeah.
We're good. So, procedure in solving, whether they are exact or not. If they're exact, then you just have to know, right? Whether they're exact or not, you take the trig equation, you rewrite it with a positive. You get the reference angle. You then look at the original and say, it's got this sign, so it's in these quadrants. You then, if you need to, sketch out, putting the reference angle into the quadrants and then figuring it out, and eventually get to the point where you may not need to sketch it out. You just say it's 38 degrees in quadrant 2, so that's 180 minus 38 is this. And use a calculator. No point losing half marks on stuff because you know you did it in your head. Well, unless it's like 40 degrees, which you should be able to do in your head. Solve each equation for theta. Round all answers. Okay, so why are they all positive? Oh, wait, there's some negatives down there. Okay, so number 1, if it's not positive, write it as positive. So these are, we're just going to leave it. So you work out theta r. You do theta r by doing an inverse sine, cos, or tan. So this will be inverse sine of 0.4672. 27.85. Oh, it says round all answers to the nearest tenth this time. So now if I want, I can go to mode and flip this to 1 decimal place. Right? Quit, and then I can just go second enter, re-enter that, and then hit enter. And I get 27.9 degrees. Since sine is positive, we are in quadrant 1 or quadrant 2, right? So Q1 or Q2. Do you want me to draw the sketch? Or do you just want to go straight to the angles? Okay. So if you need to, draw the sketches. So I'll just sketch them out for those that need to. And I might just put them all in the same diagram. Okay, so then theta is 27.9 degrees, and theta is also 152.1 degrees. Okay, and we do the same thing for cos. Okay, so just work your way through this. I'm just going to pause it. Okay, cosine is positive, so the reference angle is just cos inverse 0.898982 is 26.1 degrees. Cosine is positive, Q1 and 4. Quadrant 1 angle, 26.1 degrees. Quadrant 4 angle, 26.1 degrees. This will be 360 degrees minus 26.1. So solutions, theta is 26.1 degrees. And what's the other angle for that one? 333.9, thank you. Tan theta. Tan theta is positive. Second, I put in a brace bracket. And 3.9095. Scoop that up a bit. 75.7. Okay. Tangent is positive in quadrant 1, quadrant 3. You really shouldn't need to be drawing this for quadrant 1. Okay, so your solution, 75.7 degrees and 255.7 degrees. If you notice me make a mistake up here, please correct it before. Okay, and now the negatives. Okay, so for the negatives, you're going to start off with this. The sine of the reference angle is positive 0.2195. So let's start off with sine theta is negative. We will say the sine of the reference angle is positive 0.2915. Right? And then we just go in here. Sine inverse 0.2915. 16.9 degrees. So the reference angle is 16.9 degrees. Now, sine is negative in quadrant 3 and quadrant 4. Quadrant 3, I got a 16.9 degree. In quadrant 4, that's pretty, I know, eh? It's a huge. Sketches are for informational purposes only and may not represent actual angles. That's my best disclaimer voice. Do not attempt the following by professionally. No, do attempt the following at home, right? Just remembering the sketches are for informational purposes only and are not. So 180 plus 16.9 is 196.9 degrees, and 360 minus 17 is 343.1. Thank you. Okay, so we lead off with the cos of the reference angle is positive 0.911945. And then we go to here, we go second cos inverse 0.1945. So we have a reference angle of 78.8. Cosine is positive in quadrant 1 and quadrant 4. I'm not drawing the quadrant 1 angle because that's a waste of time. So the quadrant 4 angle is 78.8 degrees. So that's 281.2.
Why is it?
360 minus.
Wouldn't it be 2? It would be 2 if quadrants 2 and 3.
Oh, it's negative. Oh, wow. All right, let's fix that. It's good. See, everybody makes mistakes.
Oh, wow.
I would like to say I did that on purpose, but I didn't. I just messed up. So. Okay, in that case, I should draw the 78.8 degree. And okay, so what's theta? That's 91.2. Yeah? No. What is it? 101.2?
Yeah. That's what I got, and then I was confused.
It's okay. And the other one is 258.8? Okay, so it's always good to just pay attention while you're doing this. So you know, if you're doing a test, you go back, check it over, and you notice, why did I write quadrants 1 and 4? It's negative, it should be 2 and 3, and you can fix it, right? Okay, so the tangent of the reference angle is 0.653. What? Well, I don't know what the angle is yet. Let's figure out the
Sorry,
angle.
you just wrote it out. Never mind.
I'm just saying the tangent of the reference angle is 0.653, which is 33.1. Okay, well, retry it, see what you get. Maybe I made a mistake. I've already made one mistake. It's not like it's beyond the realm of possibility that I made another one. All right, see if I can get the cast rule right this time. So quadrant 2 and quadrant 4. Why did they make it difficult? What's 180 minus 33? 150, 47, 146.9? And then 330, 326.9? Use a calculator for God's sake. Okay, is it all good? Before I hit done, I hate to have to go in and make little annotation. Oh, there's more?
There's not a whole other page.
Ah.
Oh, yeah, it's just on the bottom. That's helpful.
Okay, is this the last one?
Yeah, A and B.
A and B. Ah, okay, this is important. Yes. None of the other stuff isn't, but this actually is fairly important, right? Because you're going to get questions like this. Not only now, right? It's like, you know, it's nice to be able to do it now, but you have to be able to do it, you know, when it really counts. Okay, the terminal arm of theta passes through the given, shh, pay attention. I don't ask that often, right? But this is important. Terminal arm of theta passes through the given point. Sketch the angle and determine the measure of theta if it's between 0 and 360 inclusive. Round the answer to the nearest 10. Okay, we're only going to be getting one angle, right? Because there's only one terminal arm. So we need to know which quadrant we're in. So we need to draw a sketch. So -5, +3 is going to be up here. So there's the point, and the terminal arm passes through, right? So this is -5, 3. This is the angle theta that we want to find, and this is the reference angle for theta. Sketch the angle and determine the measure, round the answer to the nearest tenth. Okay, so for this, what do we know? Well, we know that x is -5 and y is 3, right? Which trig ratio uses x and y? Tangent. So what are we going to work out? We are going to say the tan of the reference angle, right? Because if it's negative, so if we just type in inverse tan of 3 over negative 5, it's going to give us a negative quadrant 4 angle, right? Like it's going to give us an angle, and we don't want that. We want to know, so what's the reference angle? And we got to put it into quadrant 2. So the tangent of the reference angle is y over x, just 3/5. So the reference angle, they want nearest tenth, so I can just leave the calculator. So second tan inverse. So I know that tan is 3 divided by 5. 3 divided by 5, put a 3 in there. 3 divided by, what? 3 divided by 5, close that parenthesis. So our reference angle is 31.0 degrees. 31, and they asked for nearest tenth, so let's actually throw in the 0.0. Okay. Our reference angle is 31. What's our actual angle? So theta is 180 degrees minus 31.0 degrees, which is 149 degrees. So 149 degrees. Now, 3 over 5 is 6 over 10 is 0.6, right? So if I go in here and type in what is the tangent of 149 degrees, what do I expect to see? So it's going to be negative, right? So I expect to see negative 0.6. And I do. Now, the only reason I'm seeing that is because I have it set to the nearest tenth, right? So if we go back and do that again in float mode, still negative 0.6, right? But there's some change on the end, right? But it is negative 0.6. There's 10, right? So that's a way you can check. Did I do this right? Yeah, I typed in the tan 149, I got the negative 0.6, right? Okay, we're going to do the same deal with negative 2, negative 4. So we're going to sketch it out. Which quadrant is it in? So it's quadrant 3. So here's the point, negative 2, negative 4. It's a point on the terminal arm, right? So the arm passes through there. The terminal arm just goes on forever. This is the angle we want to find. That's theta. This is the reference angle in here. Okay, you don't need arrows on the reference angle because it's always positive, or it's just that. So we're going to find theta ref using tan again, right? Because we got x and y. There's no point in figuring out r and then using sine or cos. Like, why bother? Right? You got x and y. So we know that x is negative 2 and y is negative 4, and tan theta r is equal to y over x. So that's. Now, if we did negative 4 over negative 2, we're still going to get a positive, right? So it's just going to give us the quadrant 1 angle, because we know tangent's positive in quadrant 3, but based on the sketch, we know we need the quadrant 3 angle. Okay, so what's theta r? Come on, who's worked ahead? There's 10. 63.4 degrees? So what's theta? 243.4. Okay, is that it?
Yeah.
Yeah.
There's answers.